Okay, so our main goal is to discuss about random variable. Okay, so what is random variable? So when we say random variable, a random variable is a variable whose values are determined by chance. Again, a random variable is a variable whose values are determined by chance. Okay, so random variable are denoted by a capital letters such as X, Y, Z, and then the realizations or possible values of these random variables are denoted by the corresponding lowercase letters like X, Y, or Z. In short, in other words, when we say random variables, these are denoted by capital letters. And then the value of that random variable is denoted by the small letters. Okay? Again, when we say random variable, it's a variable whose values are determined by chance. Okay? Whose values are determined by chance. So what are the example of a random variable? Okay, in the coin tossing experiment, we can define that the random variable X to be the number of heads that appears from tossing a coin 3 times. Okay, that appears from tossing a coin 3 times. So the possible value of your random variables are 0, 1, 2, or 3. Okay, again, when we say random variable, what is a random variable? You determine the values through chance. Okay, so the example of a random variable is in the coin tossing experiment. Okay, coin tossing experiment, that's a chance. Okay, we can define the random variable to be the number of heads appear if you toss a coin 3 times. Okay, number of heads appear if you toss a coin 3 times. Okay, so that is your random variable, the number of heads that appears from tossing a coin 3 times. Okay, so that's your random variable. Okay, what are the value? So that's your small x. What are the value? So the values are 0, 1, 2, or 3. Why is it? How do you get that 0, 1, 2, and 3? How do you get that value? Why is it 0? What do you mean by 0? Any idea? What do you mean by 0? Meaning what? What is 0? The first value is 0. Meaning, if you toss a coin 3 times, there's no head. Okay, the first toss is tail, second tail, third tail. So meaning there's no head. Okay? So the value is 0, meaning 0 head. Okay? Next, what about 1? Meaning there's only 1 head after you tossing a coin 3 times. It appears only 1 head after you toss a coin 3 times. So same thing with 2. Okay? After you toss 3 times yung coin, the head appears twice. And then 3, meaning after you toss 3 coins 3 times, the head appears 3 times also. Okay? So that's the meaning of 0, 1, 2, and 3. Okay? Let another random variable y be the time a person can hold his or her breath. Possible values of y are 10 seconds, 20 seconds, and 30 seconds. There are many possible values. Possible values can be stated as an interval such as y is greater than equal to 10 seconds but less than equal to 60 seconds. Okay? So these are the example of a random variable. Okay? So example, determine the realizations or possible values of the following random variables. So these are the following random variables example. The first one is W, pertaining to the number of heads that may be obtained in tossing a coin and a die. Okay, tossing a coin and a die. So what are the possible values? Your random variable is the number of heads that may be obtained in tossing a coin and a die. So what will be your possible value? What will be your possible value? Number of heads that may obtain in tossing a coin. So what will be your possible values? Can anyone give me the answer? What are those possible values in determining the number of heads if you obtain in tossing a coin? Ano yung mga values na possible?
0, 1.
Okay, 0, 1. That's correct. 0 meaning?
Tail, puro tail lang.
Okay, 1.
You got the head.
Okay, you got the head. Okay? It's up to 1 only. Why is it? Why is it up to 1 only? Do we have 2? Do we have 3? Why is it up to 1? Because what?
You only toss the coin 1 time.
Okay, because you're pertaining to 1 coin. Okay, you're tossing only 1 coin. So the highest value is 1 and then the lowest is 0. Okay? Next, the number of dots on the upturned face of a tossed die. The number of dots on the upturned face of a tossed die. So what are those values? The number of dots on the upturned face of a tossed die. So what are those possible values? Sorry?
6.
Okay, 6, 1, what else?
2, 3, 4, 5.
Okay, the number of dots on the upturned face of a tossed die, it can be 1 to 6. Okay, so it depends. Okay, 1 to 6. Next, the number of king cards in getting 5 cards from an ordinary deck of playing cards. The number of king cards in getting 5 cards from an ordinary deck of playing cards. So what are those values?
Okay. 0, 1, 2, 3, 4, 4.
0, 1, 2, 3, 4. Why is it?
This because 0 because the king might not be included in the 5, and then
Mm-hmm.
only until 4 because there are only 4 kings.
Yes, there are only 4 kings in a playing cards. Next, the lifetime of a newborn baby. The lifetime of a newborn baby. So what will be the possible?
I think 1 to 90.
1 to?
90.
1 to what?
90.
90. Why is it 1 to 90?
The average life expectancy differs from different country, and then I saw most of
Yes, yes.
Because this is really hard to explain.
Okay. Mm-hmm.
Life expectancy might be ranging from around 1 to 110 as the longest lifespan.
Of a newborn baby, that's according to studies. That's according to the studies. So what will be the values from 1 to what?
1 to 110.
From 1 to 110. Okay, so these are the example of random variables and their corresponding values. Okay, and their corresponding values. Okay, so there are 2 types of a random variable. The first one is discrete random variable, and then the second is continuous random variable. Okay, the first one is discrete random variable, and then the second is continuous random variable. So what is the difference between the two? Okay, what's the difference between the two? When we say discrete random variables have a finite number of possible values or infinite number of values that can be counted. Again, when we say discrete variables have a finite number of possible values or an infinite number of values that can be counted. So in other words, when we say discrete random variable, it can be countable. Okay? So the word counted means that they can be enumerated using the numbers 1 to infinity. Okay? 1, infinity. Okay? But you can still count it. So the word counted means they can be enumerated using the numbers 1, 2, 3, and so on and so forth. Okay? It depends on the given. So the example of a discrete random variable, okay? So we have number of joggers in New Valley each day, so you can count it, okay? The number of phone calls received every day, the number of siblings a person has. So these are the example of discrete variable, okay? Again, we say discrete variables have a finite number of possible values or an infinite number of values that can be counted. In other words, discrete random variable, these are the variables that you can count it. It can be countable, okay? What about continuous? When we say continuous random variable, a variable that takes on uncountable number of values from a given finite or infinite set of values are called continuous variables. These are typically measurable quantities, okay? So you can see now the difference between discrete and continuous. When we say discrete, you can count it. But when we say continuous, in other words, it's measurable. Okay, that's continuous, measurable quantities. So the example of continuous random variable, we do have temperature. Okay, of course you can measure it. At time, person can hold his or her breath, and then height or weight or your body mass index of a person, so that is measurable. Okay, so if it is measurable, then it is continuous random variable. Okay, so for example, identify the types of a random variable. So these are the experiment, and then on the right side are the random variables. So the first experiment, roll a pair of dice. Your random variable is the sum of numbers that appear in the pair of dice. Is it discrete or continuous?
Discrete.
Okay, discrete. That's correct. Why is it? Why is it discrete? That's correct.
Because it's countable.
Okay, you can count. You can count. Okay. So what are the sum of numbers that appear in the pair of dice? What are those? Can you name those sum of numbers that appear in the pair of dice?
1, 2, 3, 4, 5, 6.
It's a pair of dice.
Joke.
Sum of numbers that appear in the pair of dice.
42.
Because it can be 2, right? Ano yung sum ng 2? So we do have 1 and 1. Am I right? Am I right? What about 3? What are the sum of 3? What are the sum of 3? It can be 2, 1 or 1, 2. And then 4, it can be 2, 2, 3, 1, and then 1, 3, and then so on and so forth. So these are the sum of numbers that appear in the pair of dice. So you can count it. So that is discrete random variable. Next, number 2. How much time in hours she spend studying for this quiz? Is it discrete or continuous? How much time she spends studying for this quiz? Is it discrete? Sorry?
Continuous.
Okay, continuous. Why is it?
It's because it is measurable.
Okay. It's continuous because there's no specific time. Try to check number 5 example. What's the number 5 example? What's the number 5 example? Try to differentiate number 2 and number 5. Can you see the difference of number 2 and number 5? In number 5, the number of hours spent watching TV from 7 to 11 p.m. In number 5, that example is discrete. Now, since we're talking about time, 2 and 5, numbers 2 and 5, number 2 is continuous, number 5 is discrete. The question is, why? Why do you think number 2 is continuous and then 5 is discrete? Try to examine number 2 and number 5 example. What have you noticed?
Number 5 has a specific time.
Okay, very good. There is a specific time. So if there's a specific time, we can, although we know that time is continuous, okay, but since in number 5, there is a specific time, then we can say that particular example is discrete. Okay, because there's a specific time. How many hours? Okay, number of hours from 7 to 11. So there's specific time. So that you can count it. So that is discrete random variable. Likewise, in number 2, how much time you spend in studying a quiz, there's no specific time, therefore, that example is continuous. Okay? So you can see the difference between the two? Next, number 3, the number of girls among the children. Is it discrete or continuous? The number of girls among the children. Is it discrete or continuous? Number 3. That's your answer. The number of girls among the children.
Discrete.
Okay, discrete. Why? Because? Obviously, you can.
You can count
Okay,
them.
you can count the number of girls. Next, weight of eggs in grams. Weight of the egg in grams.
Continuous.
Continuous. Obviously, because
It's measurable.
it's measurable. Okay? So that is the difference between discrete and continuous. Okay? Again, when we say discrete, you can count it. But when we say continuous, it's measurable quantities. So types of random variables, given the following experiment, identify the possible random variable. Okay? So taking a quiz. So these are the example of experiment. Can you give me the random variable? Let's say take a quiz. What will be your random variable? Take a quiz. It's an experiment. So can you please give me a random variable? The number of hours. Yes, my dear? What's your answer? You're saying something? What is it? So what will be your random variable? Your random variable can be how much hours you spend in studying that quiz, or it can be the number of hours you spend in studying your quiz in StatPro. Okay, so that will be your random variable. Next, ask the class about their breakfast. So what will be your random variable? Ask the class about their breakfast. So what will be your random variable?
This is the number of people who ate and didn't eat their breakfast.
Okay. So if that is your random variable, is it discrete or continuous? If that will be your random variable, is it discrete or continuous?
It's discrete.
Okay, discrete. Why is it? Why is it?
Just because you can ask them and then count it.
Okay, next. Ask a neighbor about television shows. Ask a neighbor about television shows. Can you please give me a random variable? Ask a neighbor about television shows. Can anyone give me a random variable? Ask a neighbor about television shows.
Yes.
Yes?
About how many episodes they watched.
What particular? Yes.
How many episodes they've watched of a certain show.
Okay, so if that is your random variable, is it discrete or continuous?
Discrete po.
Discrete. Okay, discrete. So if you want it to be discrete, you need to be specific. Okay, so how many episodes they watch in a particular day, so that you can count it. Am I right?
Yes.
Okay, very good. Next, ask a friend about Facebook. What will be your random variable? Ask a friend about Facebook. Ask a friend about Facebook. So what will be your random variable? What will be your random variable? Number of?
Facebook friends.
Okay, Facebook friend. Okay, number of Facebook friends. Is it discrete or random? Is it discrete or continuous?
Discrete.
Discrete. Okay. Next, run 100 meters on the track. Run 100 meters on the track.
This how much time?
Okay, time. So is it continuous or discrete?
Continuous.
Continuous. But how can we make it discrete? Run 100 meters on the track, it can be continuous, but how can we make it discrete? You said that you're talking about time, but how can we make it discrete? If there is a specific time, for example, ran 100 meters on the track for a particular time, okay, there's a given specific time, then we can say that particular random variable is discrete. Okay, but if there's no specific time, you just want to measure the time expending, and then that will become continuous. Okay, so that's the difference between discrete and continuous. Again, when we say discrete, you can count it, but when we say continuous, it can be measurable. Okay, measurable quantities. Okay, let's proceed now to probability of discrete random variable. Okay, so probability of discrete random variable. A discrete probability distribution consists of the values a random variable can assume, and then the corresponding probabilities of the values. The probabilities are determined theoretically or by observation. For a discrete random variable, the probability distribution is defined by a probability mass function, denoted by the probability or P of X, or we can read that one as the probability of a random variable. Okay? Denoted by P of X, or we can read that one as the probability of a random variable. Okay? So probability distribution for a discrete random variable, the probability distribution is defined by a probability mass function, denoted by the probability of a random variable X is equal to small x. Okay? The probability mass function can be a table, formula, or graph showing the possible values of the random variable together with their corresponding probabilities. Okay? Again, when we say probability mass function, it can be in the form of a table, formula, or graph showing the possible values of the random variable together with their corresponding probabilities. So the possible values of a random variable are called mass points. The possible values of the random variable are called mass points. For example, 3 coins are tossed. Let X, when we say capital X, you are referring to the random variable. Okay? Be the number of heads obtain the probability mass function. Okay? Obtain the probability mass function. Okay? I repeat, example number 1. 3 coins are tossed. Let X, the capital X, when we say capital X, you are referring to a random variable. Be the number of heads obtain, okay, the probability mass function of your random variable. Okay? So first, write all the possible outcomes. Okay? Means how do we determine the possible outcomes? Of course, you need to do the tree diagram. Okay? Tree diagram. So what are the possible outcomes using the tree diagram? How do we show that? Using the tree diagram. We need to toss we need to toss the coin 3 times. So we need to toss the coin 3 times. Can you see the whiteboard? Can you see the whiteboard, my dear people? Can you see it?
Yes, miss.
Okay. So how do we write all the possible outcomes for tossing a coin 3 times? So in the first toss can be head or tail. And then the second toss, okay, head, tail, head, tail. So to determine the possible outcomes, you need to do the tree diagram. And then the third toss, so we have head, tail, head, tail, head, tail, and then head, tail. Now, what are the outcomes after we come up with tree diagram? What are the possible outcomes? Can you please name the first outcome? What are the possible? Okay, we have 3 heads. Next, what else? What else?
Head, tail, tail, foot.
Okay, so we have head, tail. Okay, next. Ano next?
Head, tail, head.
Okay. Head, tail, head. Next.
Head, tail, tail.
Okay. Head, tail, tail. Next. It can be tail, head, head. Tail, head, tail. Tail, tail, head, and then 3 tails. So these are the possible outcomes. Okay? So these are the possible outcomes. Yan. Okay? So those are the possible outcomes. So if you toss a coin 3 times and it appears all of them are tails, meaning 0 head. Okay? So 0 head. So meaning your first value is 0, meaning no head at all. Next, 1 head. So 1 head, what are those? So it can be tail, tail, head, tail, head, tail, and then we have head, tail, tail. So those are 1 head. Okay? Next, 2 heads. So we have tail, head, 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 tail, head, and then 2 heads and then 1 tail. So that is the second value. The third value, which is 2 heads. And then the fourth value, which is 3 heads. Okay? So meaning, there's no tail. So after you toss a coin 3 times, it appears all of them are heads. Okay? So 0, 1, 2, 3, these are the value of your random variable. Okay? So these are your value of your random variable. Because your random variable a while ago says that you need to determine the number of heads appear if you toss a coin 3 times. So these are the value. 0, meaning after you toss a coin 3 times, there's no head appears. Okay, then 1, 2, and then 3. So these are the value. Okay? So in general, the properties of probability mass function are as follows. Probabilities should be non-negative. What do you mean by non-negative? There's no negative answer. Okay. So the probability that the random variable x is equal to small x must be greater than equal to 0. Okay? So meaning there's no negative, non-negative. Next, the sum of the probabilities of all possible values of a random variable is equal to 1. So if you add all the probability, the sum must be 1. Why is it? Because the highest value in probability is 1, and then the lowest is 0. Okay? So the lowest is 0, the highest is 1. If you're talking about probability. Okay? Example. Okay, so going back. 3 coins are tossed. Let x, when we say capital X, you're referring to the random variable, number of heads, obtain the probability mass function of your random variable. So how do we solve that? So to solve, first you need to identify your possible outcomes. Okay? Like what we did a while ago. What are the outcomes? So that will be your sample space. So the outcomes are 3 heads, 3 tails, and then tail, tail, head, tail, head, tail, head, tail, 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 head, 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 tail, head, 2 heads, and then tail, and then 3 heads. So these are your possible outcomes. So that is your sample space. Okay? When we say sample space, you're referring to your possible outcomes. Okay? Next, probability of each value of the mass point. So we need to determine each probability. Okay? So we need to determine the probability of each mass point. So what do you mean by that? So the probability of getting no heads is 1 over 8. The question is, Miss, how do you get 1 over 8? How do you get 1 over 8? The probability of getting no heads, meaning 0 head, is 1 over 8. The question is, how do you get 1/8?
There's the number of outcomes, po, and is the 8. Is the 8. Because the one with no heads is only 3 tails.
Okay, 3 tails. So that will be 1/8. Okay, next. The probability of getting 1 head is 3/8. The probability of getting 1 head is 3/8. Okay, 3/8. The question is, how do you get 3/8? How do you get 3/8? How do you get 3/8?
There's 3 outcomes with only 1 head. 3 over 8 since there's 8 outcomes overall.
Okay, very good. Okay, next. The probability of getting 2 heads. The probability of getting 2 heads is 3/8 also. Why is it? Where do you get 3/8? Because
There are 3 outcomes with
2 heads out of how many?
Out of 8.
Okay, out of 8. Next, the probability of getting 3 heads. What is the probability of getting 3 heads?
1/8.
Okay, very good. 1/8. Why is it? Why is it?
There's only one outcome with 3 heads
Out of?
out of 8.
Okay. Out of 8 outcomes. Okay? So those are your probabilities. Okay? So those are your probabilities. So let's continue. So 3 coins are tossed. So let X be the number of heads obtained, the probability mass function. Okay? So the probability mass function can be written or can be in the form of table, formula, or graphs. Okay? Probability mass function can be in the form of a table or a tabular form or using table. You can rewrite it in a formula form, or you can sketch it using graph. Okay, so there are 3 ways to write a probability mass function. So it can be in the form of table, graphs, or formula. Okay, so using tabular form, okay, using table. So the number of heads, so 0, 1, 2, 3, okay, so 1, 2, 3, and then the probability of each value. So if the number of head is 0, so the probability of getting that 1 is 1/8. If the number of heads is 1, so the probability of getting that 1 is 3/8. Then the number of heads is 2, so the probability of getting that 1 is 3/8 also. And then the number of heads is 3, so the probability of getting that is 1/8. So this is your probability mass function using table form. Okay, using table form. So that is your probability mass function. Okay, note that the 2 properties of a probability mass function are satisfied. The probability distribution can also be represented using, again, formula or graph. Again, probability mass function can be used or can be written in the form of table. Okay, the example a while ago can be written as a formula and graph. Okay, the question is, Miss, how can we write that using the formula? Okay, let's proceed, and then I will teach you how. Okay, so this is the graph of your probability mass function. Okay, so the graphical representation of the probability distribution of X. So the horizontal, okay, 0, 1, 2, 3, you're referring to the value, okay, the number of heads. So that is your horizontal line. For the vertical line, these are the probabilities. Okay, so these are the probabilities. Okay, for the vertical line, you need to write the probabilities, and then the horizontal line, you need to write the number of heads. Okay, so that's how we graph probability mass function. Okay, so toss a fair coin 3 times and define. Okay, so X the number of times the head shows. So, yeah. Okay, so we're done with table, we're done with the graph. So using formula, how do we write the probability mass function? So using the formula, okay, so using the formula, we can write the probability mass function, this one. The probability mass function of X is the probability that the random variable X is equal to X 0.125. What is 0.125? Meaning what? So how do we write that? How do we write the probability mass function using the formula? So using the formula, we can write that. So the probability mass function of the random variable X equals to X. Okay. So first we need to write the probabilities. So 1/8 if X is equal to what? 1/8 if X is what? 1/8 if X is 0 and 3. Next, 3/8 if X is equal to what?
1 and 2.
Okay, 1 and 2. So this is your probability mass function using formula. Okay, so this is your probability mass function using formula. Okay, so we're done with the table, we're done with the graph, and then this is the formula. Okay, so you need to write first it's their corresponding probabilities and its value. Okay, if the probability is 1/8 if X is 0 and 1. If the probability is 3/8 if X is 1 and 2. So this is your probability mass function using the formula. Okay, so using the graph, so same thing. In the horizontal line, you need to write all the values, and in the vertical line, you need to write all the given or the corresponding probabilities. Okay, so we call this graph as histogram. Okay, histogram. So this is the graph, and then the other one is the formula. This is the formula, and then this is the graph. Okay, next, number 2, construct a probability distribution for the sum of the result from rolling 2 dice. Construct a probability distribution from the sum of the result from rolling 2 dice. So how do we answer number 2? How do we answer number 2? we need to construct probability distribution for the sum of the result of rolling 2 dice. Okay? So using table, yan. So these are the sum. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are the sum. Okay? X is referring to the sum of dots shown after the tossed. So yun, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are the sum. Okay? So the probability of getting 2 as the sum is 1 out of 36. Miss, why is it 36? How do you get 36? Because you're referring to what? You're referring to dice, 2 dice. Okay? So it's 36. So 36. So the sum of getting 2, the probability of that 1 is 1 over 36. Okay? What is the probability of getting the sum is 3? That would be 2 out of 36. What are those? It can be 2, 1 or 1, 2. And what would be the probability of getting the sum is 4? What is the probability of getting the sum is 4? How do you get 3 out of 36? What are those? What are those? Ano ba yung sum ng 4?
1, 3.
Okay, 1, 3. 2, 2. What else?
3, 1.
Okay, 3, 1. Okay, next. What is the probability of getting the sum is 5? What is the probability of getting the sum is 5? 4 out of 36. So what are those?
1, 4, 4, 1, 2, 3, 2, 3, 2.
Okay, and then so on and then so forth. The question is, Miss, why is it up to 12 only? Why is it up to 12? Why is it there's no 13? Why is it up to 12? What's the reason behind that? Why is it up to 12? Because?
Just because 6 is the largest number in one die, and then times 2 is equal to add it to 12.
Okay, very good. So this is your probability mass function using table. Okay? So this is your probability mass function using table. So using the graph, okay? So again, the number in your horizontal line will be the number of the sum of dots after you tossed, and then the number in your vertical line will be the corresponding probability. Okay? So the corresponding probability. Now, what will be your probability mass function using the formula? Can anyone give me the probability mass function using the formula? What will be your probability mass function using the formula? Can anyone say it? What will be your probability mass function? Using the formula, how do we write it? Using the formula, in formula form. We're done with the table, we're done with the graph. So how do we write the probability mass function using the table? Using the table. How do we write it?
This 1 over 36.
Okay.
This is x
X.
is 2x12.
Okay, 2 and 12. Next. Next. Continue.
2 out of 36
Okay.
is x is equal to 3 and 11.
Okay, next.
3 over 36
Mhm.
is x is equal to 4 and 10.
4 and 10. Next.
4 over 36
Mm-hmm.
is x is equal to 5 and 9.
5 and 9. Next.
5 over 36 is x is equal to 6 and 8.
Okay, next.
And 6 over 36 is x is equal to 7.
Okay. So that is our probability mass function using the formula. Okay, let's continue. So a box contains 4 red, 5 blue marbles. Pick 3 marbles. Z, the number of blue marbles picked. Now the question is, can we write the probability mass function using the table? So using the table, so what will be the values? What will be the values? Z pertain to the blue marbles pick. So what will be the values? Can you give me the values?
0, 1, 2.
Okay, 0, 1, 2, 3. Why is it up to 3 only? Why is it up to...
Because you can only pick until 3 marbles.
Okay, 3 marbles, 3 blue marbles. Now, what is the probability of getting 0 blue marbles? Okay, so what's the probability of getting 0? So what's the probability of getting 0? Meaning, the 3 marbles is not blue. All of them are All of them are red. So how do we answer that one? So to answer that, so we have, how many red?
4.
Okay, 4. So 4 taken 3 multiply by 5 taken 0 over 9 taken 3. Okay? 4 taken 3 multiplied by 5 taken 0 over 9 taken 3. Means, how do we get that? Why is it 4 taken 3 times 5 taken 0 over 9 taken 3? How do you get this? How do you get this? How do you get that? How do you get 4 taken 3 over 9 taken 3? How do you get that? Meaning the 3 marbles came from red. All of them are red. So meaning that will become 4 taken 3 multiplied by 5 taken 0 over 9 taken 3. Can you please check this one if they have the same answer, which is 1 over 21? Can you please check? Combination of 4 taken 3 multiplied by 5 combination 0 over 9 taken 3. Can you please check if they have the same answer, which is 1 over 21? Can you please check? Is it the same? Can you please check?
Miss, wala po yung 5 taken 0.
Yeah, it's okay. Can you please check?
The same lang po.
Okay, same. So what is the explanation? Meaning, if the first value is 0, meaning the 3 marbles is not blue, okay? So the 3 marbles are red. So you need to get the 3 marbles to the given 4 red, okay? So we have 4 taken 3 multiplied by 5 taken 0. But why is it 5 taken 0? Meaning, hindi mo kunin yung 3 marbles sa 5. Okay? Kasi 0 blue eh. So ibig sabihin, the 3 marbles that you pick are all red. That's why it's 5 taken 0. Okay? All over 9 taken 3. Why is it 9 taken 3? Why do we need to divide it by 9 taken 3? Because how many marbles do we have? How many marbles do we have? How many marbles?
9.
9. There are 9 marbles. So out of 9, we need to pick how many?
3.
Okay, 3. Okay, so that's how we get probability. Okay, using combination. Okay, next. So you do have 1 out of 21 probability. Next, if the value is 1, meaning if you pick 3 marbles, okay, there are only 1 blue, and then the rest are red. So how do we get the probability? So 5 taken 1. Why is it 5 taken 1? Because the 1 blue marble came from 5, because we do have 5 blues. Okay? And then the remaining 2, we need to get it where? We need to pick it where? Sa red. Okay? That's why you do have 5 taken 1 multiplied by 4 taken 2 all over the total number of marbles that we have, which is 9. And out of 9, we need to pick 3. So 9 taken 3. So therefore, the probability is 5 over 14. Okay, next. What if the value is 2? Okay, meaning, out of 3 marbles, there are 2 blue marbles. So how do we determine the probability? So to determine the probability, that will be 5 taken 2. Why is it? Why is it? 5 taken 2, why is it? Why is it 5 taken 2?
Was 2 blue marbles.
Came from?
Came from the 5
Okay.
blue marbles.
And then the other one, kasi kailangan natin 3 eh. So yung 2 manggagaling sa blue, what about the other one?
The other one comes from the red.
Okay, comes from the red. So that would be 4 taken 1. All over the total number of marbles, okay, which is 9, and we need to pick 3 out of 9. So I do have 10 over 21. So 10 over 21. Now, next, number 3. The value is 3. The value is 3. How do we solve that? How do we determine the probability? How do we determine the probability? That the 3 marbles that we pick are blue. How do we determine the probability? There's another solution to solve this. There's another solution to solve this. There's another solution to solve this.
Yes. Count all the possible outcomes and then get the 5 because there are 5 blue marbles.
So we have, if we need to get the probability of getting 3 marbles, meaning 5 taken 3 multiplied by 4 taken 0 over 9 taken 3. Okay? 5 taken 3 multiplied by 4 taken 0. Why is it 4 taken 0? There's another way to answer this one. There's another way to answer this one. 5 taken 3 multiplied by 4 taken 0. Meaning, all 3 marbles came from blue marbles. Yung all 3 marbles came from blue. So 5 taken 3 multiplied by 4 taken 0. Why is it 4 taken 0? Meaning, walang red. Okay? Lahat ng marbles are blue. So 4 taken 0. Meaning there's no red. Divided by the total numbers, which is the total number of marbles, which is 9. And out of 9, we need to take 3, regardless kung anong kulay. Okay? So that's how we get the probability of each value. Can you please check if they are the same? Is it the same? 5 over 42 pa rin? Can you please check? If we use this one, is it the same? Still the same? Okay. Okay, still the same. So the probability is 5 over 42. Now, after we get the probability, what will be your probability mass function using the table? So using the table, your probability mass function will be what? Can anyone give me the probability mass function using the table? This one is the formula. This one is formula. What about the table? How do we write the probability mass function using the table? How do we write the probability mass function using the table? This one. Okay, this one. This is your probability mass function using the table. Okay, 0, the probability is 1 over 21. If the value is 1, the probability is 5 over 14. If the value is 2, that will be 10 over 21. And then if the value is 3, so you do have 5 over 42. So this is your probability mass function using the tabular form. And then this one, okay, this is your probability mass function using the formula. Okay, so how do we write the probability mass function using the formula? This one. Okay. So you know how to graph a probability mass function? The number in the horizontal line are what? How do we graph the probability mass function? What are the numbers in the horizontal line? These are what? The numbers in the horizontal line are the number of blue marbles. And then the number in the vertical line, okay, that's how we sketch the graph. Okay, the number in the horizontal line are the number of blue marbles picked. And then the number in the vertical line, their corresponding probabilities. Okay, their corresponding probabilities. So that's how we graph probability mass function. Okay?